Hi, in this lesson, I'm going to go over some homework questions from 2.2, 2.3, where I'm going to determine whether a given statement is true or false using a true table. And then the next thing I'm going to discuss is the whether a given argument is valid or not using a series of valid arguments. So to make that conclusion, which is question number 45 from your homework. So let me start with number 1. Okay, so this is number 11 in your homework in 2.2. This one here is to determine whether this statement, the compound statement over here, is valid or not, given that P is false. I know P is false, Q is true, and R is false. So I'm not just making a true table for everything. I already know the value for PQR. So I set it up as I would do a true table in instead of one, but now I'm not doing the whole table. I only need to know when P is false, Q is true, R is false. So let me set it up. So I would set it up as PQR on my first row here, QR. And then on the right hand side over here, I basically directly copy down this one down here, same thing. I just add space in between here to construct this one row true table. Now, note that recall from the lesson, lesson 3, we said that to construct true table, we work inside out. We look at the things that most inside of parentheses, look at simple components, the connectors, and then we look at outside the parentheses, which is the bracket, and then look at the parentheses. So last thing I look at is the connector that connecting the both component here together. So this and here are going to give me the true value of the whole statement. So let me do it. Okay. Since I'm given the P is false already, I don't have to write all values. So P is false, Q is true, R is true. Okay, I only need 3 things. So that's what I have here. Now, I'm going to fill in the simple components inside out. So I have P is false. Negation of Q must be false because Q is true. So therefore, the N here, this connector right here, the N is true if both components are true. Since both are false, this is false. Okay. Now I look at outside the parenthesis, which is look at the bracket. Now inside the bracket, there's a simple component over here is a negation of R. Since R is true, so negation of R must be false. Oh, so negation of R is false. Next thing I did is, let me put a R1 over here so you label my order. I look at the connectors here. I'm labeling the connectors only in this case. And then once I finish this negation of R, I look at this middle. Now this OR here connecting this component with this component. Okay, so I'm going to erase it here so you see clearly. So since in column 1 gives me a true value of this compound statement here, and we have a false followed by a false, and we have an OR, we say OR is true if at least one of the components is true, but since both are false, this is still false. Okay, and that is, I'm going to make this column 2. Now I'm going to look at the parenthesis on the right hand side. On the right hand side here, I have Q, I have R. Just bring the value Q and R over. So this is false, this is true, and I'm looking at the N. Again, N is only true if both components are true. So therefore, this is false. And I'll make this my column 3. Now, to look at this N over here, I'm going to use the true value for the left-hand side of this statement and the true value for the right-hand side of this statement, which is given it to me by column 1 and column 3. Now, notice that in column 1 and column 3, they're both false. So, therefore, the N here must be false. So, now I found the true value for this statement. Given P is true, Q is true, R is false. So, this statement is false. So, the given statement is false for the given condition of PQR. So, the given statement, okay, P and negation of Q or negation of R and Q and R is false for the given condition for let me just write it out, for P is true false, Q is true, and R is true. So the answer is false here. Oh, I'm in the highlight, so false. So that's my final answer. Okay. Now I'm going to go to question 67 on section 2.3. Now for this question here, I notice a lot of common mistake that I see. One of them is that a lot you just tell me true, false, and never really provided with me a reason why it's true or why it's false. So let's consider a statement. I know the absolute value of x is a positive number if and only if. This tells me that I have a biconditional statement and x is not equal to 0. Now to do this statement here, I could just use notation for it. I can let we did like we make the truth table. So let's recall here, let's rewrite it. If and only if I use the notation for this notation here is for biconditional statement. Okay. So I'm gonna rewrite this using my biconditional statement. I'm gonna let the first statement here, this part of the statement as my P, and I'm gonna let this as my Q. Again, you don't have to be PQ, it could be A and B, C, D. Now here I'm just for convenience, I'm just put PQ. So this is my Q. So I'm gonna write it. So okay, P represent the statement that absolute value of x, okay, is a positive number. Okay, I'm gonna let Q be the statement that x is not equal to 0. Then this whole statement here in symbolic form, I have P if and only if Q. So this statement in symbolic form, I have P if and only if Q. Now let's recall the conditional statement for true value. Let's recall in the previous lesson we learned that for PQ, let's just write it out, the very simple component, and P if and only if Q. We said that for PQ to be, if I have two components here, so I have true, true. Let me extend the form for first. False, true, false, true, false. I said for biconditional to be true, both of these components have to be the same. So that means in the first row and the last row here, both are true. This is true. And we have false in the middle right here. So false, false. Okay. So that's just something this is what we did in lesson 3. So you're not sure, I encourage you to go look over your notes again. So now let's go back to my statement. I'm going to draw a little small truth table for the statement, just using some examples. So we said biconditional statement is true if both of these components are the same. So let me write it. So I'm going to draw PQ. I'm going to draw using X and Y, X here. Pick some X values, just to get understanding. So I say, I'm on one column, I'm going to make an X value. Just organize my work. I have P, I have Q, and then I have my statement, P, which is representing the given statement here in notation of Q. And then I'm going to draw my column. Let me draw my row. Okay, so I have this. Okay, and then I have my column. Let me just write some few number. I don't have a lot of them. I just need a few, just to give you an idea what it means. So I can say this one says for any real number x and y. That means I can pick any x, and I want to know whether this statement is true or not. Remember, recall in lesson 1 we said to show something is false, I need to find one counter example where for a given x that this statement is false. So I need one to show it false. Otherwise, if there's none, it could be true. So let's just consider situations. Think about numbers. Well, number can pick anything I want. So let's say this question says if and only if equal to not equal to 0. Well, let me pick 0, see what happens. So when x is 0, okay, let's consider p. Then I would have absolute value of 0 is equal to 0. So the first component P here, P is a positive number, while 0 is neither positive nor negative. So Q is 0 is neither positive nor negative, so Q must be false. So I have false over here. Now let's look at Q. Well, Q says x that's not equal to 0. Well, 0 is equal to 0. So 0 equal to 0 is just, but this one says 0 does not equal to 0. So this is false because 0, it does equal to 0. So this is also false. Well, false, false in the biconditional, this is give me a true value. Okay, that's what happened when x is 0. Let's pick something that when x is not 0. Okay, so let's say I pick, let's say, I don't know, any number you want, negative 10. Okay, let's say negative 10. Well, for negative 10, we know absolute value of negative 10. Let me just write it out here better. So P is my absolute value of x, which is absolute value of negative 10. This is just 10. So 10 is a positive number. So this is a true statement. And for 10, about x not equal to 10, so 10 does not equal to 0 is also true. Well, for true value, both components are true. My biconditional is also true. Okay, I pick 0, I pick a negative number. Let me pick a positive number, see what I have. So what I say, I pick 5, for example. Well, for if I pick 5, I would say, well, 5, I have absolute value of 5 is still 5. So P is true. I substitute here, P is the positive number. So this is true. Okay. Well, 5 does not equal 0 for sure. So, wait. So 5 does not equal 0. So therefore, it's also true. So both are true, therefore true. So no, that doesn't matter what number I pick. I range of things. Could be positive, could be negative, could be 0. At the end, my column for the statement is always true. Notice that this is always true. Okay, so something that's always true, we call tautology. In this case here, I would have this is tautology. This is always true, therefore the given statement is true. So therefore, I can make the conclusion that the given statement is true. So therefore, the given statement is true. Okay. So this is what I mean by showing work here. So I'm drawing a little small table and give me an example of things. And I consider all type of example possible here. Know that negative 10 just represent all negative number. 5 use positive number. So you can plug in more number to check it out. You will see that it's still true. So this is homework question 2.367. Let me zoom in so you see the whole thing. Okay. Now let's move on to the next one. Okay. The next one is number 45 in homework 2.4. Now, before we do the statement, let's recall the standard form here. This is the valid standard form for valid arguments. And so if you want more discussion on this valid arguments, I would say look at example lesson 3. In lesson 3, we did quite a bit of those. So let's do this question. Use a sequence of valid argument to show that this argument is valid. So again, I'm going to keep that in mind here when I do my argument. So this is a note that I keep in mind. Keep this in mind. Think about it. So let me, well, when I make an argument, first thing I do, I just copy down the premises and write it down and then use it. So, oh, notice that there's a little typo right there. This line should be over here. Okay, because the premise 3 is still my premises here. This is the part is my conclusion. So this should be the better here. So now let's write it. So I have 3 premises. So my goal is to rewrite it. I notice that premise 1, premise 2, well, it doesn't look like anything that I know look like any of the standard form here. Does it look like? Let's see. So let's look at the first premises at a time. Let me write it down. So I say solution. Okay, let me just write it out as the beginning. I'm going to copy the first premises, see anything I can use it. So I have negation of P implies R. That's my first premises. I'm just by P1 here for premise 1. I'm going to copy my second premise. R implies T. And that's my second premise. Now, I want to, based on these 2 premises, is there any conclusion can I make? Does this look like any one of the standard form we have over here? So let's think about it. I have negation of P go to R. Think of the conditioners here, the arrow here as your like bridges. So not P go to R go to T. This look like the law of syllogism right here. So notice that I have P go to Q, Q go to R, therefore P goes to R. So same thing over here. I have negation of P go to R goes to T. Therefore, for the conclusion, I could say negation of P goes to T. Oh, let me write it better. If, again, this is a conditional statement, and this is true by law of syllogism right here. So I'm going to write my reason. This is true by law of syllogism. Now, notice that I used both premises already, but I haven't used premise 3. Now, I'm going to copy premise 3 down. I'm using my conclusion combined with premise 3 to see what kind of conclusion I come up with. So I'll write down premise 3. So negation of T, that's given to me by premise 3. Now I want to see what kind of conclusion can I draw using the conclusion from the previous step and the premise 3. Well, negation of P goes to T. I'm negating T. Well, negating T here is just the second standard form right here. This is the modus tollens. Notice that I have conditional statement, then I negated the consequence, which is Q, and then my conclusion is the negation of first part here, which is my incident. So the conclusion is the negation of the antecedent. And see, look at here. I have here. Let's examine it closely. So I have the same thing. Notice that this is the same thing. I have a conditional statement. The second piece over here, the second premise here, is just a negation of second component T. And therefore, my conclusion is a negation of the antecedent, negation of P, it becomes just P. So my conclusion here is therefore P is true. Now, notice that this is true because we are using modus tollens. So I'm writing my reason for it. I'm using modus tollens. Okay. And notice that this is exactly the same conclusion for my argument. This is the same thing here. So therefore, the given argument is valid. Okay. So now I say the given argument is valid. Is okay, valid. And this completes the homework questions. Okay, thank you for watching. I'll see you next time.